We're back today talking about speed and velocity. Yesterday we discussed distance and displacement and the difference between them, and that's going to come in handy and be important when we discuss speed and velocity. As you can see, something you're very familiar with is speed already. It is a scalar quantity because we're only going to use numbers and units associated with it, but basically speed is how fast an object is moving. If you're moving fast, you have high speed, and if you're moving slow, you have low speed, or not moving at all, you have zero speed, something that we're all very used to already. For velocity now, it is a vector quantity, and since it's a vector quantity, we are going to have to be concerned about the direction associated with it. But it is the rate at which an object changes its position, and as we see and dig deeper and look into its equation, we'll start to see how velocity and speed are actually quite different. In this picture here, we see a motorcycle that just turns and is going at a constant 5 meters per second northwest. Since it's going straight and the gentleman is at a constant speed, its speed and its velocity will continue to be constant. The reason again for that is because the direction and the speed is not changing. Now take this second motorcycle. Since the gentleman is turning, and say he turns at 5 miles per hour and makes a left turn, even though his speed remains constant, since his direction is changing, his velocity is going to change as well. So interesting enough, the constant speed will be there, but velocity will not stay constant. And last, after that turn, the gentleman now is going straight, northbound, with 5 meters per second. Since the direction and the speed does not change, both the speed and velocity are considered constant. The equation for average speed is quite simple. It's just the distance traveled by the object divided by the time of travel. Since distance is measured in meters and travel of time is measured in seconds, the units would just be meters per second. So that's for average speed. Velocity is a little different. Since it is a vector quantity, it's dealing with a component that's a vector, which is displacement. We know displacement still is measured in meters and time in seconds. So velocity would still be meters per second. But since it's dealing with change in position or displacement, we now know that velocity is going to have to consider direction as well. So that's your average velocity. If you take a look at this little picture here, we do want to discuss instantaneous speed and velocity. And that is just the speed or velocity at that absolute particular instant. When you look at the speedometer of your car, it's telling you your instantaneous speed, which is the speed at that moment. In fact, when a police officer clocks you, he's checking your instantaneous speed. So if we read the little description down here below, the speed limit applies to your instantaneous velocity, not your average velocity. That's only partially true. It's technically your instantaneous speed he's checking because he's not taking into consideration your direction. Now, obviously, if you were driving on the wrong side of the road and speeding, he would still pull you over for numerous reasons. But the speed limit does indeed only talk about the speed of a vehicle, not the velocity, which takes into consideration the distance. If we look at the sample problem, the cross-country skier is going from A to B, then B to C, and then C to D. If we wanted to talk about the average speed, from A to B would be about 180 meters. And then from B to C, it would be 140 meters. And then from C to D, it would be 100 meters. The total distance then is 420 meters, and that's over a time of 3 minutes. So if we're looking at our average speed, it would be 420 divided by 3. That would give us 140 meters per minute. And then you would want to convert that from meters per minute to meters per second. Now, if you wanted to find the average velocity, and forgive me, that's misspelled there. Velocity is the displacement over time. So the average velocity is going to just be the displacement, which is between point A and D. And that is actually 140 meters. And it took place over the same amount of time, which was 3 minutes, just like for speed. And if you took 140 divided by 3 minutes, you would end up getting an answer of about 46.6 meters per minute. And that, of course, is quite different than the average speed that we calculated. So to prove a point, it shows you that there definitely is a difference between average speed and average velocity. And that direction component, the idea of vector versus scalar, certainly makes a difference. Now let's say we took that 46.6 meters per minute and we wanted to convert that from 46.6 meters per minute into meters per second. To do that, it would be simple. Meters would stay there, but we'd want to get rid of minutes. So I would put minutes in the numerator and seconds in the denominator. And I know for every 1 minute, there's 60 seconds. Well, minutes would cancel out, and I'd end up just having it be 46.6 divided by 60. That ends up giving me an answer of about 0.78 meters per second. Just an idea and a reminder that conversions will be quite important throughout the year. But that concludes our discussion on speed and velocity and some of the problems that we'll have with it. Best of luck, and thanks for listening.